So now we know that these acids which we were assuming to have been containing H plus ions right from the beginning, it's not that they always generate these H plus ions. They will generate these H plus ions only in the presence of water. And since we were talking about only water solutions till now, we always had our H plus ion. And so the acid behaved like an acid. So actually, when your HCl is added to water to make an HCl solution, it actually reacts with the water molecule. Actually, what happens is that first the HCl will dissociate into H plus and Cl minus ions, because in aqueous solution the ions will break up. So you have your H plus ion, but this H plus ion, if you see that H has only one proton, one neutron, no neutrons. It has only 0 neutrons and it has one electron in its outermost or first orbit. Now this H plus will remove this electron, and what will be left is one proton. Now this one proton, if you see that the proton will not be able to exist independently. Well, I mean, you can't have a stray proton going here and there. Then protons need something to hold on to. So this H plus, which is a proton, will react with a water molecule, or not react, just get attached to this water molecule and make an ion called the H3O plus ion. And this H3O plus ion is called your hydronium ion. So till now what we were thinking, that acids have H plus ion, so these H plus ions are not actually present, but they are present in the form of H3O plus ion, but both are equivalent. That means H plus ions and H3O plus ions, while using for reactions, will be equivalent, because it's just H3O plus is H plus and H2O. So this is our hydronium ion. So, and similarly, our sulfuric acid H2SO4 will generate two H plus ions and SO4 2 minus ions, and these H plus ions will get attached to this water molecule, forming H3O plus ions. So this also forms your hydronium ion. The properties of H3O plus are only due to H plus. That means H2O is just a you can say something for H plus to hold on to. Otherwise the properties are all due to H plus. Water does not change any properties of this H3O plus. Now similarly, our base, as we say that acids generate H plus ions only in the presence of water or moisture, so a base will also produce OH minus only in the presence of moisture, that is H2O. So OH bases are also similar like acids. They will only produce these OH minus ions in the presence of water. dry bases will never produce your OH minus ions. And this, suppose we have KOH. What is this? Potassium hydroxide. And we add water to it. Here the hydronium ion is not formed. I mean hydronium, there is nothing like some ion is formed and it will get attached to this water. It's just plain dissociation of KOH, K plus and OH minus. OH minus ions are very stable. They are not like H plus ions which are only just a proton. So OH minus ions generally exist by themselves. They don't need to attach to any water molecule to exist. So this exists only in water in the form of this. And this is responsible for its basic properties. And if you have NaOH, it's similar. This will produce Na plus and this will produce OH minus. That is why, you know, this base is due to this OH minus. It is not due to any K plus. So even if you put K plus or Na plus or Ca2 plus or Mg2 plus, it will still remain a base because you have OH minus. As long as you have OH minus, it will remain a base. And in acids, as long you have H plus or H3O plus, it will remain an acid. Now, so this is our next topic of concern: dilute and concentrated acids or bases. So we have heard these terms many times: dilute and concentrated. Suppose you have a juice and you add, you have some lemon juice and then you add sugar to it and you add very less sugar. So, and the taste is not very sweet. So you say that the juice has become very dilute because there is very less sugar in it. And in concentrated, if you add lots and lots of sugar to one glass, if you add half a kg sugar, then it tastes very sweet and you say that it has become very concentrated. So this dilute and concentrated, these terms are actually dependent on how much water is present for the solute. So in this case you have water and you add sugar. So you have 1 glass of water and you add 0.5 kg sugar or 1 kg sugar to it. So that solution will become very concentrated because you are adding a very large amount of solute to a small amount of water. Now if you increase this amount of water, then you will see that your solution becomes lesser and lesser concentrated and it tends to go towards dilute. So it basically depends on the relative quantities of the solute and the solvent.